Hi everyone, Krishna here, and I hope you all are doing great. Today, we'll design another popular system design Android question, that is designing a stockbroker platform like Groww Kite. And in this design, we won't focus on how stock exchange manages the orders or generate the latest stock prices. Instead, we'll assume that the exchange already exposes the APIs for those particular functionalities, and our job is to consume those APIs, like processing the user request and sending them to the exchange. For example, whenever user places an order, our system will forward that request to the exchange, and exchange will process the order and return the status. Okay, so with that in mind, let's start noting down the functional requirements. So the first thing is like let's define what are the things that are out of scope. Okay, so we won't cover user registration, KYC verification, authentication, brokerage calculation, or even the pricing and similar features unless interviewer specifically asks us to include them. Our primary focus will be receiving the latest stock prices from the exchange and displaying it to the users, and we'll also provide historical stock prices as well. Next is like users should able to place the orders. The platform should support both the market and limit orders. And for those who are not familiar with these type of orders, limit order is basically it allows the users to specify exact price at which they want to buy or sell the stock. If the current market price does not match the specified price, the order remains in a pending state until stock reaches to that particular price, or order is basically cancelled by the user. Okay, and in case of the market order, it is executed immediately at best price, whatever the market price is going on. For example, if stock is trading at 200, and when user places the order, the actual price execution could be like around 208, because the stock price may change very quickly. So yeah, that is the market order. So yes, apart from this order placement, we'll also support features like Watchlist, allowing users to track their favorite stocks. So let me quickly note down all the functional requirements right over here. Yeah, these are a couple of functional requirements that I discussed. The first is like receiving the latest stock prices from the exchange and displaying it them to the users. Then historical stock price information for a particular stock, that is also a feature that we will support. Users should able to place the order both in market or limit orders, and will allow them to track their favorite watch list, so they can add all the different stocks and they can see the latest stock prices that are getting displayed for those stocks. Okay, yeah, these are a couple of functional requirements. Now let's focus on non-functional requirements. So the first is obviously when we discuss about cap theorem here, when user place the order, right? So during that point in time, the system should be highly consistent. Okay, we cannot afford availability right over there, and if there are any failures in the network, if the order placed incorrectly, obviously we will incur with the financial issues, and that is something we cannot afford it. Even if the system, if there are issues with the network and the system is not working, so it is okay to not process the order or cancel the order, and we can retry it after some point in time, but we have to ensure that the system should be highly consistent during order placement. The next thing is when we are receiving the stock prices, during that time it is okay to get the latest stock prices. Even if some fluctuation is happening, we should at least display the latest stock prices. So during that time we will try to ensure that the system is highly available. So yes, those are the things that we will consider right over. And apart from these, like we have to ensure that the system is durable, highly scalable, and even the security and all those things will be there. So I'm not noting them down, but yes, these are the two things that I'll note it right over here. Low latency and all those things obviously come into the account at any point in time whenever we are discussing and designing these type of systems. So yes, let me note down all those two functional requirements, non-functional requirements, and then we'll talk about the scale of the system as well. Okay, yeah, so let's talk about the scale now. Let's suppose we have 100 million users available on the platform, and daily let's suppose 20% of users are using the application, so 20 million active users we have. So 20 million is like 20 into 10 to the power of 6. Now, among these, uh, most of them generally prefer to keep eye on the stocks, and they will just keep looking into the stock prices. And only few of them basically place the orders. So yes, let's try to get the throughput per second basis. So 20 million users, they are generally, I mean, making, let us suppose 20 network calls, or to just keep it simple, like 10 network calls they are making generally, and they are keep on watching 10 stocks on daily basis. Okay, so if we try to get the throughput per second basis, let's just divide it with 10 to the power 5. I'm not getting the exact number right over here, so just to make it simple. And if we try to do this, the answer is like here 100 into 20 is 2000, and again like this 10 to the power 5, and if we cancel it out, like 20k requests we are getting per second. Okay, so these many network requests we are getting it, and among them, let us just assume that 10% of requests are generally uh, the order placement requests. Okay, so it is like 2k requests we are getting it per second to place the orders. Yeah, so this is the throughput, and during peak time, if we try to multiply it with 2, obviously like 4k or even 10k requests, we are generally seeing it for order placement per second basis. And yes, this is the scale that we are gonna deal with while designing the system. Okay, All right, so let's start designing the system. The first thing is obviously client started making the request to get the latest stock prices and see they wanted to place the orders and all, right. So those are a couple of options the client started making right over here. And what we'll do is like they have to first communicate with the API gateway. There will be a API gateway load balancing and all to make sure that the request they are making will be properly authentication, rate limiting, and all those operations we will do before allowing them to hit to our servers. So yeah, now these requests started coming to us, and the first thing is like they wanted to get the latest stock prices, right? So there will be a stock price tracker service. We'll be having a stock price tracker service, and let's add a couple of servers. So it will be horizontally scaled, obviously. Stock price tracker service, and now the idea is the stock price service generally talks with exchange, right, to get the latest stock prices. So there will be an exchange who will provide us the latest stock prices. So in India we have two exchanges, NSE and BSE. From there we can get the stock prices, and generally the brokers pay a huge amount of money to these exchanges to get the APIs from them. So yes, we'll be having exchange whose job is to provide us the latest stock prices, and then even when we start placing the orders, the exchange make sure to process that order and then give us back the whatever whether the order has been successfully placed or not. So yes, those are a couple of tasks these exchanges generally do, and we are not going in deep dive into this exchange side. Our job is to just create the stockbroker platform. Okay, now we are getting the stock prices. Stock prices job is to provide the latest stock information, the prices and all to the clients. So the communication between these clients and stock price tracker services, like if we simply create an HTTP connection, obviously client may not just simply track one particular stock, right? They wanted to get stock prices every second, every minute and all. So yes, the communication shouldn't be like simple HTTP way. There should be either a WebSocket connection or it should be an SSE connection. That is something what we can establish right over here. So the general idea is if we create an WebSocket connection, the connection between the client and stock price tracker service is bi-directional. So it will be always open from both the side. But the idea is when we send request from the client for a particular stock, like a client wanted to get stock prices of Reliance, okay, and they keep on monitoring that particular stock, right? The whatever ticks, latest ticks that we are getting it, that is only what they generally keep on watching it. So is it really necessary to create an WebSocket connection right over here? Because the idea is client once make request to the stock price tracker service, their job is done. They just wanted to retrieve the latest stock prices. That's all. They don't want to keep on sending any other request other than just keep on tracing the stock prices. So here the best thing is like we can create a SSE connection right over here. That is server sent events. Okay. So that is like single direction connection. The only thing is like at the first time client make the request for a particular stock. Like this is the stock that I want to see the latest price of that particular stock, and then the stock price tracker service, that is the server, its job from the server is like whatever latest stock information that it is getting, it will keep on sending the prices in form of events. Okay, that is the SSE connection that we will be establishing right over here. So instead of keeping a bi-directional connection using WebSocket, here what we can do is client first initiate connection request for a particular stock, and then it's server's job to send the stock prices in form of events. So the connection here that we will be establishing right over here is an SSE connection. So once client make a request, the server's job to send the latest stock prices instead of client keep on asking for latest stock prices. Okay, so yeah, that is the connection that we will be establishing right over here. And then now here talking about this from exchange to stock price tracker, right? So we don't want to expose our internal servers directly with the exchange, right, to get latest stock prices from here. And for that what we can do is we will be having dedicated uh, exchange gateway right over here. We can call it as exchange gateway. So that is another thing that we will be having right over here. So yes, here we will be having another exchange gateway that will be ours. Okay, so this exchange gateway, what it does is like any particular request that we are sending it from our side, either to get the latest stock prices or even placing the order and all, that goes through this exchange gateway. There will be multiple such instances, and then we can have load balancer where we can put the exchange request in particular exchange gateway. So that is something what we can have right over here. And now the exchange gateway communicates with the this exchange and get the latest stock prices. So here also again the exchange keep on sending us the latest stock prices. Again here the same thing that comes into account whether we have to create a WebSocket connection or SSE connection. The idea is generally in most of the interview cases, so people generally say SSE connection is something we can again establish, because the job is like from exchange side. The exchange is basically sending latest stock prices per millisecond basis, like in milliseconds, whatever the latest stock prices that are coming, right? So they just keep on pushing it back to our exchange gateway, and the exchange from the exchange gateway we can feed it to the clients. but most of the cases, like we can generally say other SSC connection is something we can establish, but in real life scenario, most of the time, majority of company clients, they use WebSocket connection to get the latest stock prices. Okay, so we will establish here a WebSocket connection, because it is fine, like we can have a connection open for any other cases as well, but yeah, it is generally preferred to use either of that based on the use cases. So I'll be using here WebSocket connection to get the latest stock prices, and even placing the orders and all, like let's have open connection from both the sides. Okay, now from this exchange gateway, whatever latest data that we are getting it, we are just putting it into the stock price tracker and giving it back to the client. But there is something like historical stock price information for a particular stock, that is also we have to keep on monitoring and giving it back to the clients, right? They wanted to see data in per minute, second, and all those things are also there into the account. So for that, we have to ensure that some persistence connection is something what we have, either some database where we can keep on feeding the latest information to the database, and from there we can give it back to the stock price tracker, and then it will feed it back to the clients. So what we can do is, since we have, like in India there are 5,000 plus stocks that are there, and that continuous information is something what we are getting it right over here in the exchange gateway, right? And we cannot directly feed it to the stock price tracker. So what we can do is, we will be having here something called Kafka to stream that massive amount of data to the stock price tracker. So it is like event streaming platform is something we require right over here to stream that data constantly to our services. So what we will do is, we will be add another layer, and that will be Kafka right over here. So let's add it. Okay, just added Kafka right over here, and there will be a topic called stock price, something like that, which collects the latest stock prices constantly from this exchange gateway. Now, from Kafka, we can directly feed the information to stock price tracker, but this mechanism is like pull kind of mechanism, right? Like from stock price tracker, we have to constantly pull the data from Kafka. Instead of that, we can have a publisher subscriber kind of mechanism right over here between this stock price tracker and the Kafka. We what we'll do is, like, we again have to hold the historical data as well, right? So we'll be having two layers here. The first is like to get the latest stock prices, we'll be adding another service called this will be, let's say, price consumer service. And this service, what it will do is, it will push get the latest stock prices, and we'll be having again like multiple instances of these particular services. Let's add them as well. So we'll be ensuring any particular stock which has high trading volumes, all the data basically goes splitted across different brokers, and we have to again collect them right over in the price consumer, and then we have to ensure that we will be adding that into a pub sub mechanism, something that we are discussing right over here. So there will be like Redis pub sub, that is something what we can use is Redis pub sub. Okay, which basically this consumer publishes the latest stocks, and the stock price tracker basically subscribe to this Redis pops up, and from there, like whatever latest stock prices that are there, this stock price tracker keep on getting it from this Redis pops up. Okay, so let me just color it differently, and yeah, we are done. So from this Redis pops up, the stock price tracker subscribes to all the stocks, and latest stocks information is something will get it constantly, and from there we will feed the latest stock information to the clients. Now again, from here Kafka, we will be having another service. These are the consumers for DB. Okay, I'll name it as DB consumer. And what it basically does is, like all the latest stock prices it gets, and its job is like put it into the database. So we'll be having DB right over here. This DB, we cannot simply rely on simple database. Okay, we have to ensure that since millions or even billions of records we are getting it on daily basis into this database, right? Because constantly in milliseconds, for a couple of stocks in milliseconds, the latest stock prices are constantly coming us, and we have to feed it into the database. So obviously you can understand that generally it trades for 6.5 hours on daily basis, and for each particular 5,000 such stocks, we are feeding it at information per second basis, or in millisecond for a couple of stocks. It will be really a big task for us. So obviously simple database cannot work here, so we have to ensure we will be using some time scale DB. Okay, time series DB, which basically works upon the Postgres. So the database we will be using is time scale DB right over here. Okay, because the time series database are highly optimized for these type of systems. Okay, as in we require data for 1 hour basis, 1 minute basis. So time series DBs are highly optimized for such type of tasks. So any historical data that we want it for this stock price tracker service to feed it to the clients, will directly communicate with this time scale DB, and we'll get it back from here and feed it into this one. Okay, yes, just rearrange the things. Now let us focus on this time scale DB, like how the table will look like. The first thing is, like, we'll be having symbols, stock symbols. It could be Reliance or anything like that. Then timestamp. So that is another column. Then there is price, stocks low, where it has been hit, because it requires for the tick, right? So whatever the ticks that we generally see, for that we require this high, low, volume, these informations. It could be Reliance. Then the timestamp is like 10:00:01. Okay, the price is like let's suppose 12:30. Low it hit it at 29 point something like that, and high it got is something like that. Volume is like 2000. This is how the data basically we are feeding it inside this timescale db. And the idea is we have to ensure that the timescale db, whatever database that we are using it, we cannot simply feed it in one database, right? So we have to ensure the database that we are holding here, it is properly get sharded. And what we can do is generally like the first thing we simply can do is based on stock symbols we can shard this database. So Reliance, which generally get highly traded, or even some other stocks or options like bank nifty and all. So for them, like we will keep on separate shardings, sharded dbs, and inside there all the any incoming data that we are getting it, we are just simply adding it in those particular sharded database, right? That is the first thing. Like other ways, like we can even shard it based on the timestamp. That is also another thing that we can consider. Or the best is like with the symbol and the timestamp we can shard the data generally, like whatever the particular stock symbol that is we are having from January to June for that particular stock, we can combine that data in one particular shard and we can create those different shards. Okay, so that is also another thing that we can consider here for this database to ensure that data is something what we are feeding it properly, and we are not having any problem with this holding this much of high volume data as well into the database. Okay, yes, those are a couple of things. Now the idea is pretty much simple. So client establish connection to get the latest stocks. So whenever they want to see any particular stock information, so there will be an SSC connection. So the stock price tracker, whenever client make a request, their job is to keep on sending the stock in form of events to the clients. Okay, and there will be a dashboard upon which the client can keep on seeing the latest stock prices and all in a form of text or even in a form of charts and all. Now the next is like the stock price tracker get the historical data from the timescale db, and that is how it feed the data to the clients. And to get the latest stock prices in milliseconds, like we will be having Redis pub here. So the stock price tracker keep on making the request to the Redis pub. I mean there will be this subscriber mechanism. So this will subscribe to this Redis pub to get the latest stock prices, and the Redis will keep on feeding that data. I mean since it already subscribed to right over here. And we'll be having Kafka right over here seeding, which collects the stock information, which is basically having high volume data that is keep on coming from the exchange. And there will be having two different services. First is like db consumer, which feed the data into the database, and then there is a price consumer which consume the data and feed it into the Redis pub. So yeah, that is the flow for stock price tracker to get the latest stock prices all the way to the clients. Now next is like we will be having clients keep on maintaining their watch list and all, right? So yes, so there can be another watch list service we can have here. And this service is generally, I mean obviously like it will be horizontally scaled again, and we can call it as watch list service. And we will be having database. There will be a simple SQL DB right over here which holds the uh, prices. Okay, stock price, I mean sorry, it's not stock prices for particular user. We can have user ID right over here, user ID, and the stock symbols. Okay, so it could be list of all the stock symbols they are basically holding in their watch list to get the latest stock prices upon their screen. Okay, so stock ID or symbol, something like that, we can have list of stocks. That is something I can name it right over here. So this is something we can have right over here. So anytime user opens the application and they are looking into their watch list, so this watch list, what it does is generally it talks with this stock prices, and it will send a list of stocks for which the users generally wanted to see the latest stock information. Okay, so we can have here this communication between them. There are a lot many ways to get the latest stock information in bulks, and from here we will feed it all the way to the clients. Okay, yes, that's how we can get the latest stock prices, the list of all the stock prices, and feed it all the way to the users. Now our next task is just accepting the orders from the clients, and we have to ensure that those orders get placed from the exchange, either whatever status that we get it, whether it got accepted, rejected, and all. So something like that, we have to process it, and we have to send a notification to the clients as well. For that, what we'll do is like as the client started making requests, we'll receiving those all the orders into order service. Like that, here we have this order service which started receiving all the orders, and its job is basically validate all the orders that we are receiving it. And see, the problem is at some point in time there could be a lot of traffic burst as well. So we have to ensure that we'll be having some event streaming platform right over here like Kafka, or in general, like we can scale out all these services to handle this that level of traffic as well. Okay. Once we receive all the orders, what we will do is generally like the first thing is like we have to ensure that the orders are getting persisted at our level as well. So we'll be having a DB. So this is our database. It can be a simple relational database. So what all things that we can have inside this database is like the order ID, user ID. Okay. Next is like stock symbols, price, when it got updated. Okay. So updated at created at. And then next is like status is also another important thing. So yes, status. So currently whenever we receive the order, the status is basically in pending state. Okay, so currently it is in pending state. Okay? And once we get acknowledgement from the exchange gateway via this exchange, whatever status we get it, whether it got accepted, rejected, that is something what we will update inside this DB as well. For reconciliation as well, we can have this database so that we'll see later like why these orders got failed or something like that. Anything that we want to check, we have to ensure that the data is basically getting persisted at our place as well. So now once we update the data into the database, so this order service can simply communicate with the exchange gateway and send that order into this exchange. And now it's exchange job to process that particular order, and it will give the acknowledgement to this exchange gateway. And once we receive the status, either it got accepted or rejected, failed partially, something like that, we'll update it into this database and we'll send a notification to the clients as well. Yes, that is the job. But the idea is like, let us suppose in normal cases, these orders were getting processed by exchange because the traffic is very low. But at any point in time, if burst is something what we got it, like so many clients started placing the orders, there this particular flow cannot help us at any point in time, right? So we have to ensure we will be having some uh, event streaming platform between this order service and this exchange gateway to ensure that the burst of traffic is something what we are not directly pushing it into this exchange gateway, and we have to ensure we will be placing here Kafka to make sure that those orders were getting placed properly. Where the topic could be like order placement, something like that we can have. Yes, so this Kafka will handle all those incoming traffic, and then its exchange job is to pull those order events and give it to the exchange. Once we receive the status for all those orders, we'll be putting it into the Kafka again, because the job is heavy, right? Like we have to ensure that we will be updating it into the database. Then we are sending the notification to the clients as well. So it is better to have another topic. It could be like order status, something like that. So let me just copy this. We have the order status topic. Let's name it as order status. So what we'll do is like this order status topics. There could be another consumer right over here which has the job to update this database, and then we'll have another notification service which basically send the notifications to the clients from wherever they are using it. Like it could be an Android application, iOS application, or all. So yes, that's the reason like I am using another Kafka topic here. And once we receive it, like it'll simply update this into this order service, and whatever status we are getting it, we'll update it into the database, and then we will send the uh, status of that particular order to the client as well. Okay, that's how the flow basically works. I hope you got the idea. So the idea is like client started placing the orders, the order service validate all the orders, and then it will update into the database with pending state. Once its job is done, like it will put that order into the Kafka. Now Kafka basically help us to avoid burst volume that we are directly pushing it into this exchange, and the exchange gateway pulls all those events and give it to the exchange. Now at any point in time, let us suppose a particular order from the exchange side did not get processed in given time frame. Okay, so it's exchange gateway's job to see that the orders that this exchange gateway sent, why it didn't receive the acknowledgement from the exchange. Okay, so if a particular time is something we passed, let us suppose 30 seconds, so the exchange gateway will ask a question to this exchange, what is the status of this particular order, since the user ID is basically unique. So obviously like we have to ensure that user ID and order ID is not combined. We are asking for there because user may place multiple orders. Yes, that is something that this exchange gateway basically do to ensure that what is the status of that particular order. And again, it will retry multiple times if we still did not receive any information from this exchange, any kind of acknowledgement we are not receiving from the exchange. We can put it into the queue, some related queue, and from there we will retry again to see whether the order can be placed or not. Okay, that is something what we can do if any response is not we are getting it from the exchange side. Okay, yeah, that's the flow. I think the order service is pretty much straightforward, like what we have to do right over here. I hope you get the idea like how the things are working right over here. If so, please make sure to like this video. Thank you for watching this one. Bye bye.